Hello. The K-means clustering algorithm, which is a very well-known and common partitioning algorithm that we will study today. We have seen that in partitional clustering, a data set S containing n objects is distributed among the K clusters, where K is the parameter given to us, it is input to us, into disjoint clusters C1, C2, Ck, such that each belongs to the set and mutually they are disjoint. These clusters are formed so as to maximize the similarity within the objects in the cluster, and we also want that the objects within a cluster are dissimilar to objects in other clusters. K-means and K-midoids are well-known partitioning methods, and these use the concept of centroids to represent the clusters. So centroid based partitioning technique, it uses centroid. So we have shown in this example two clusters partitioning 8 points, and in the bottom side we have shown the left side cluster has means as the representatives. These mean points are actually this mean point here, the mean point here is actually a computed value, and similarly for this second cluster also. However, the second diagram shows us the midoids, which means which are actual data points. See, if we look at our diagram here, we compare these two. So there is a data point here where we have placed this red hexagon. So this is a data point which has been chosen to represent the cluster, and we call it a midoid. We will later see K-midoids algorithm, which uses midoids as the representatives. So two approaches in the centroid based techniques, one where the mean is used, which is shown here in the left side diagram, and the other one where the midoid is used. The K-means algorithm, we just write down the steps, choose the initial set of K-means or centroids, we call them centroids, or means or centers sometimes, iteratively reassign the data points to means, recomputing the new means every time, and continue until convergence criteria is reached. The error is reduced to a desired level, or no change in the change in the means is below a threshold, or it could be no change. We must note the K-means method can be applied only when the mean of a set of objects is defined. Okay, so we are talking about objects where a mean can be computed. Let us go through the example from the previous video. Here we had taken 8 points. K equal to 2 was given to us. And in the first iteration, we had chosen M1 and M2 as M1 was point A and M2 was point C. So this was the first iteration we got. Then in the second iteration, when we recomputed the means from this first assignments, A, B gives us M1 and the rest of the points give us M2, and we reassign and we get these assignments, 4 data points here, 5 data points here, and 3 here. We recompute the means and do the assignments and see what happens. There is no change. So this is the final clustering we get when we start from A and C, which is 0.5, 0.5 and 1, 2 as the initial cluster means. Now we come back to the same example with different initial means. So the problem statement is same, 8 points, 2 clusters, and let the initial means now be D and E. D 2.5, 2.5 and E is 4, 2. So compute distances. We have again computed the distances. and assign points to the closest means. So here we see the closest values of A, B, C, D are to M1 and of E, F, G, H are to M2. So these are the clusters we get, A, B, C, D in the first cluster and E, F, G, H in the second one. Recompute means. So we recompute the means for these 4 points as 1.5, 1.5 and these points as 4.25 and 3. Compute distances, method is same. And now we see what happens. Same 4 points are close to M1 as in the previous iteration ABCD and EFGH are close to M2. So cluster assignments do not change. This is the previous iteration cluster assignment and even this one would do the same. So what happened? We took the same set of 8 points but started with 2 initial means. Now, okay, before we compare, I will just briefly, we wrote the second example is summed up here. There were 8 points, 2 clusters. First iteration, we get 4, 4. Second iteration, again we get 4, 4 and that's it. So, when we took the second time we took the means of DE, we needed 2 iterations and our cluster assignment completed. So what did we see here? The choice of initial means has an impact on the k-means clustering. When the initial means was AC, we got these as the final clusters. C1 was ABC, C2 was DEFGH. And when the initial means are DE, we get C1 as ABCD and EFGH as the C2. So which one is better? We started with an arbitrarily chosen set of means and we got 2 different set of clusters. C1 in the first case has 3 points, C2 5 points, while in the second case, both the clusters have 4 points. So, we need some kind of optimization function or validity measures to find out which is the better clustering. This we shall do in our next video. Thank you. Thanks for watching.